is similar to what we've been doing in the last couple sections. Yesterday we were looking at proving continuity at a single point. Today we're looking at continuity over an interval. Okay? So a function is continuous on an interval. So this might be from 1 to 7. Or it could be negative infinity to positive infinity. If the function is continuous at each point of the interval. So obviously we cannot prove that at every single point on the interval. Because we can't show at 1 and 2 and 2.2 and 2.7 and 2.9 and 3.999. We can't check every single one of those points. So when we're looking at continuity over an interval, it's not so much that you're going to be proving that it is continuous. You'll be looking for the discontinuities is what you're going to be doing here. So the following functions are continuous on all points in their domain. Alright, so polynomial functions, this could be like a quadratic, x squared, x to the third, x to the seventh plus 2x cubed minus 4. Those are all examples of polynomial functions. All you really need to know is if you see something like that, it's continuous. Okay? Rational is going to be continuous everywhere in its domain. But the domain for rational, the denominator cannot equal 0, right? So you might want to put your note right here, denominator.
Is a rational a real number, or is it a square root, or is it a fraction?
Rational is a fraction. It is also a real number. But you might be thinking of a whole number. There are numbers that cannot be written as fractions, such as pi. Pi is irrational. You cannot write it as a fraction with real numbers. Irrational, like square root of 2 is irrational. If you get a decimal that continues on forever, but does not repeat itself. So like, pi is 3.14, 159, blah, 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 blah. And so that decimal continues on forever, but it does not repeat itself. So it would be irrational.
I don't remember it either.
A number like 1 point... What if I got 1.3 repeating? Is that rational?
Yeah.
I don't know.
It does go on forever.
Yeah.
But it repeats because this can be written as a fraction. That's 4/3. So repeating decimals are rational. But decimals that go on forever without repeating are not. Most square roots, if you cannot take the square root of the number underneath the square root, those are irrational. Yes, so that would be the case unless it's a perfect square. But there are other numbers that are irrational, such as pi or e is irrational. So I need to have you guys watch a video on e that I watched the other day. That's so interesting.
What's the point of
I'll have you watch it one day, but I'm gonna wait till we get to some stuff we're doing e with a little bit more.
Yeah, I don't understand.
Yeah.
like, you know how pi has a circle? What's the... It's
We don't have time for this. Y'all ain't gonna get your homework even started in here for real. All right. Power function is it can be x to any power, which would include stuff like x to the 1/2 power and x to the 1/3 power, or it could just be like x to the 7th, which is also a polynomial. Any number.
Oh, I didn't know that was a
Well, then what's
I
thought that was a
Yeah. Exponential. I'm not going to list right.
Wait, hold up. What's the difference between power and polynomial?
Polynomials can be power functions, but like x to the 1/2, that is not a polynomial.
Okay.
Like x to the 7th could also be a polynomial, but
And x squared plus 2x plus 4 is not a polynomial.
right, because I think it has to be just
Just
the x.
Oh.
Like x to the third is a power and polynomial.
Yes, it could be both. It's not terribly important that you know the names of all of these. It's just that when you see stuff like this, you know that it's continuous on its domain. Exponentials, we know about those. That's like 3 to the x power.
What's the difference between exponential
So here, your number is on the bottom, your x is in the exponents. Right here, you have numbers for your exponents. Right here, you got.
But can you replace an x?
So it's like 1 to the second and 2 to the third. 2 to the second, whereas exponential is 2 to the third, 2 to the second.
You just said the same thing.
Yeah, you just
I literally didn't say the same thing.
So your
About.
your variable is in the exponent for exponentials. The variable is the base for these. It's on the bottom.
It doesn't really matter. It's just for me to know.
If you see an exponential, it's continuous, right?
Yes.
Logarithmic we're familiar with. Log of x. We'll see natural log of x is the one we're going to use the most in this class. They are continuous on their domain. Whatever your x is here has to be greater than 0. So whatever you're taking the log or natural log of, whatever's on the inside has to be greater than 0. That's for your domain here. I'm not going to answer that question right now because we need to get these notes done. But I have a really good video we might watch on it sometime soon. All right. It is 2.1, no, 718, something.
I remember that.
Yeah. Okay. All right. All right. And trig functions, you guys are familiar with trig functions. They're continuous. All right. So,
Give me an example.
Like cosine.
all right, polynomial functions. Your domain, I kind of already did this. I should have looked ahead. Your domain for polynomial functions is negative infinity to infinity, all of them. So that's, again, that's like something like x squared plus 5x plus 4. Yes.
Isn't domain x?
Yes, x values.
Good job.
Sometimes things change.
All right, I already wrote this down, but for rational, the denominator,
So why, if it's x values, is there a y value? Yeah. This is domains, not.
all right, so this, I'm using interval notation here. So it's from negative infinity to positive infinity. Those are both x values. Yes. So I'm using interval notation here, which we use some in pre-cal also. You also could write it, you could also say all real numbers. And this symbol right here, this R with the double bar, that also means real number, all real numbers. So any of those are appropriate. Yes. Yes. She's getting ready to leave. Alright, power function, if you have an even root, so we're talking like here x to the 1/2, which would be like the square root of x, or x to the 1/4, which would be the 4th root of x. If you have an even root, then what would you have to say about the domain of that? What can you not have for your domain? Negative numbers. Can you have 0?
Is it because whenever
What's the square root of 0?
0.
It is 0. It exists, so you can plug in 0. So I'm going to just write this. This is a fancy word, radicand. Sounds like a 17. It does. The radicand has to be greater than or equal to 0. So what's underneath the square root has to be greater than or equal to 0, because you can't have negatives under the square root. Exponential, this is x to the 1/2, which is equal to the square root, yeah. 1/4 is equal to the 4th root. Yeah. Those were just examples of what I mean whenever we're talking about even root. Exponentials are always our real numbers, unless you have crazy stuff like square roots inside of exponentials or something like that, but we're not going to be dealing with those. Yeah, always all real numbers for anything I'm going to give you anyway. Here. Logs, there might be a fancy name for what you're taking the log of, but I don't know that there is. So, what you're taking the log of has to be greater than 0. You cannot take the log of 0 or a negative number. So, like, if we're talking about log of x, then our domain would have to be x is greater than 0. Alright, and trig, I'm not going to go as much into trig, but I will tell you for sine and cosine, those are continuous everywhere, negative infinity and positive infinity.
You used the wrong door. How did you say that?
You're right.
What you are taking the log.
Yeah.
How is that the wrong
I fixed it now. I did not have the apostrophe. I didn't have the apostrophe.
It was
Alright.
Y-O-U-R. You should have done U-R. You didn't write like because you're not named this person.
Why would anybody do it?
I thought he was gonna actually drop it. Alright, Mister.
Alright. Okay. Alright. Tangent and secant, cosecant, all those, they have discontinuities. We're not going to go into a lengthy discussion of that right now. Alright. So, for this problem, it says to show that f of x is continuous on the interval from 2 to infinity. So for this, we can't prove this in the same way that we were doing all those steps to prove at a point, because we can't prove every single point. But what we do want to do is look for the discontinuities. So for this graph, where do we have a discontinuity?
You would have that out one.
Okay. All right. So ignore the interval for right now. Just look at the function. All right. So f of x has a, what type of discontinuity do we have there? A non-removable, I'm just going to go ahead and say it's a vertical asymptote. At x equals 1, but is continuous on all, or let me say for all other x. is not a hole. It is a discontinuity. But non-removable can either be a vertical asymptote or a jump. In this particular case, it's a vertical asymptote. Jumps are going to happen on piecewise functions. It does not cancel with anything in the numerator. If it cancels, you've got a hole. If it's just 0 in the denominator, it's going to be a vertical asymptote. Okay? All right. Since, and this is continuous everywhere else because we know that rational functions are continuous everywhere on their domain, right? Since x equals 1 is not on the interval negative, 2 to infinity, f of x is continuous. On this interval.
So we're just basically saying that it's continuous, but it has a vertical asymptote.
Correct.
This continues at one point, but that one point is not a domain.
Yeah, since 1 is not between 2 and infinity.
Yeah.
If this was negative 2 to infinity, it would f of x would not be continuous on that interval.
What is the bracket?
Bracket is like having a less than or equal to or a greater than or equal to.
Oh, okay.
It includes the point. A parentheses is like having a less than or a greater than. They have tennis. You do not. You are not on the ladies' tennis team, so you do not get to go. I'm not basing it on anything except for the fact your name was not on the list of ladies' tennis players. All right. Okay. All right. Okay. So this graph gives us it's made up of a line segment, a point, and a piece of a parabola. And it is called g of x. And we're supposed to tell whether or not g of x is continuous on the interval from 4 to 8 and why. Okay? Alright, so 4, whenever it gives you intervals, think about vertical lines, like sectioning off with vertical lines. So 4 is right here, and 8 is right here. So if we only look between those two red vertical lines,
Oh, so interval notation.
I thought you meant like the coordinate error. Yeah, that ain't how coordinates.
okay, this is interval notation. So another way that this could be written is 4 is less than x less than 8.
Now, how are we supposed to differentiate between?
Whenever you see interval,
Oh, that's right.
yeah, it'll say at the point.
Is g of x continuous on the interval 4, 8?
Okay, so between these two red lines, do we have any discontinuities? No. So we would say g of x is continuous on 4 to 8 because you got a few it says why, so you got to say because. A couple ways you could say this. I would say parabolas, or let's say quadratics. Well, let's go parabolas. Parabolas are continuous functions there. You also could say because there are no discontinuities, or the discontinuity does not occur between 4 and 8. Yes, I think that would be fine. Especially when you're dealing with a graph, because you would be able to see what's happening there. All right, what about though if I take this one red line right here and I move it down here to -2? So now I'm looking on the interval from -2 to 8. And I've got those brackets, so it's including. That means we're doing -2 less than or equal to x less than or equal to 8. Is my graph continuous between those two red lines? No. Because I've got a hole in the graph right here, and my closed circle doesn't fill it in. So I would say no, because now where is that discontinuity? What's the x value where it occurs? 3. Okay, what's the problem with this?
There is a point.
Okay, so g of 3 is my point, right? It would be okay if g of 3 was down here, but it's not. It's up here. So g of 3 does not equal what? Limit as x approaches 3 of g of x. So the limit would be the open circle. That's what you approach from both sides. It does not equal g of 3. Therefore, g of x is not continuous at x equals 3, which is in that interval, so it's not for me.
I understand it better when I use a graph.
Like graph better. Yeah. Okay. Let's look at a couple more. Okay. F of g of x. I just got to plug g here. So f of g of x is going to be 1 over square root of x plus 2 minus 5. Okay, so if I'm looking right here, I'm going to check out g first, right? X plus 2 has to be greater than or equal to 0, right? Which means x has to be greater than or equal to -2. Because if I plug in any number less than -2, like -4, I'm getting negatives under the square roots, which is undefined. So I can already tell you the answer to this is going to be no, just because of that. But I also am concerned with this whole thing right here being equal to 0. Right, just in case, let's pretend maybe it said -2 to infinity here. So if I've got square root of x plus 2 minus 5, if I add 5 to both sides, square root of x plus 2 will equal 5. squared, x plus 2 equals 25, and subtract that 2. X equals 23. So I also cannot have the number 23. Right? So I would say no, because f of g of x is not defined for x is less than or equal to negative 2 or x equals 23. I'm kind of giving it like backwards there because I said it's not defined. I could have said, I guess it might have made more sense if I said it's only defined for x. Well, I like it better this way.
You don't need that number equal to.
Oh, you're right, I don't need the or equal to right here. I'm going to fix that. X is less than negative 2.
No, because that's saying
Up here I was saying where it does work. Down here I'm saying where it doesn't work. Okay? Questions? These are basically finding the domain. That would be your domain. Here. Okay? Alright, so this one's a piecewise function. But it's one of these piecewise functions where whenever you see something like this, where it's just that x equals 3, all this is right here is the point 3, 3 on the graph. Right, it's just a single point there at 3, 3. So everywhere else, and that's a not equal to, it's kind of ugly there. But everywhere else you're using this top function. So what you want to do for this is you want to see if that dot fills in what's probably going to be a hole in the graph right here. So you can do that by doing the limit as x approaches 3 of x squared minus 9 over x minus 3, which if you no, because that tells me that I got a hole in the graph. But what I want to know is, does this dot fill in that hole? Because if the dot fills in that hole, then it's continuous. Right. And there it cancels. We plug in 3. 3 plus 3 equals 6. So does our dot fill in our hole? What would I need to have for it to fill in the hole? 3. It'd have to match this 3. Not 0, but 3.
I knew I had to equal 0. I know I had to equal 3.
Yeah.
Negative 3.
Yeah.
6.
Yeah. So we would say we want to describe the intervals on which this function is continuous. So in this case, it didn't ask us to say if it's continuous. We're supposed to describe where it's continuous. This is going to be continuous everywhere except what point? 3. So if you're using interval notation, you would write it like this. Negative infinity to 3. Use a parentheses there. I always get this mixed. Is it? Yeah, I think it's that.
Yeah.
It's not the U, or is it the U? I gotta look. We're not right now. Use this one. I need to go look that back up. I get mixed up on it every time. And then from 3 to infinity, because I use the parentheses here instead of a bracket, it's not including the 3. Or inequality, which AP exam is going to use both. It's going to use interval notation sometimes. It's going to use inequality notation sometimes. You would say x is less than 3 or x is greater than 3. I'm pretty sure it's upside down.
Which do you want us to practice?
You need to be able to to be able to recognize either one. So it doesn't matter to me, like on homework and stuff, which one you use. If it's free response, it doesn't matter which one you respond with, as long as it's correct, it's fine. But the questions you're going to see would have interval or inequality. So you need to be able to know both of them. All right, last one. Wait, do you not have one more?
No, just 5.
Example 5 is the last one.
Oh, there's an empty slide there for some reason. Okay, so if I want to know where this is continuous,
Oh, like the homework.
it's like the homework. This is a lot like the homework. So E, it's continuous everywhere, right? Exponentials are just always continuous. What about this x to the third plus 2x? Continuous? I'm going to look at the piecewise in a second. But I'm just looking at each individual piece. Exponentials are continuous. Cubics, continuous. What about this one? So, x minus 2 cannot equal 0. So, x cannot equal 2. Is that on this interval? It is. So, there's one discontinuity. X cannot equal 2. I'm going to write that down. There's one problem. So, that's going to be one place where this is not continuous. Cosine, continuous everywhere. So, this little piece right here is the only one that within its section has a discontinuity. But we're also going to have to check where the pieces of our graph come together. So at -1, I'm going to do e to the -1 and see if it equals -1 to the third plus 2 times -1. That's 1 over e equals -1 minus 2. Is that true? It is not. So x cannot equal -1. You got to jump in the graph there because you're not getting the same value. Even you don't have to simplify. We also have to check at 0. So 0 cubed plus 2 times 0 needs to equal 5 times 0 over 0 minus 2. This over here, of course, is just 0. This is 0 over -2. Both of those are 0, so we're good at 0. It is continuous at 0. And then the last thing we need to check is our 4. So we plug in 5 times 4 over 4 minus 2, and it needs to equal cosine of 3 times 4. So I got 20 divided by 2, which is 10. Cosine of 12? Okay. So we don't know cosine of 12, and this is in radians, not degrees, so we don't know it. But what do you know about cosine? It's always between 1 and -1, right? So does it equal 10? No. So it doesn't matter if you know that value. You know that x also cannot equal 4. So I like interval notation better. So I would say -infinity up to -1. And then from -1 to 2. Correct. Running out of room here. Drag this over a little bit. 2 to 4. And then 4 to infinity. This is where it is continuous, because our question asked us to tell what intervals it was continuous for. Alright, we did finish to give you a little time, but it's just 12 minutes, not a lot.